Answering the question 6, preconfiguration. The first step is logging into the orchestrator called Salsa as administrator. Here we have the global view of the application performance, including application SLAs and trip. Following step is activating the Edge appliance. On the application dashboard, we can see several parameters as site names, active systems, services, etc. In this setup, we have 100 appliances. On the site dashboard, we have a more visual view of the appliances associated to 100 corresponding sites. The dashboard includes a number of parameters like LAN WAN LAN capacity, usage, and application SLAs. Now, to simplify the configuration of the appliance, I'm going to clone an existing configuration. I need to include the name of the site. So I'm going to use Bristol as an example. Its region, which is Europe, and UK as a country. I can also add a tag corresponding to the type of the site, and we're required to specify the name of the appliance, IP engine Bristol in this case, and its private and public IP addresses. So this parameters by default, and the one selection method in this case is CPE IP addresses. Other methods are available as well. Link speeds of the 3 available links are 10 megs for a DSL primary link. We require the CPE IP address, 2 megs for the second link of MPLS, its IP address as well, and 2 megs for a ADSL third link, requiring also its IP address. Controls and mobile agents as part of the services are needed. So now IP domains of the LANs associated to the Edge appliance are required. Each appliance has at least one domain associated. So here we have 100 Edge appliances. Cloning an existing domain, I use Bristol for the name. I specify the IP addresses of the LAN domain and associate it to the appliance site called Bristol as well. Next step is verifying that the packets of applications that will be detected and classified are part of the standard dictionary. For instance, the related antivirus protocols, the cloud protocols, or the UCC protocols should be included. We can manually include protocols, IP addresses, sockets, URLs, common names, etc. So, our last preconfiguration step is defining QoS profiles. For example, I'm going to clone a voice real-time QoS profile. I use Audio Skype for Business. 3 types of global profiles are available. I select real-time. Objective bandwidth is 120 kilobits per second. Max is 150. So delay, jitter, and packet loss are by default. First use case, voice traffic uses the best performing available path, including Internet or MPLS. I need to create here a new application group to associate one or more applications and protocols to a group, QoS, and path control policies. You can see several existing application groups here, including Voice over IP. I clone Voice over IP application group and call it Audio Skype for Business. Select top criticality. I use Audio Skype for Business QoS profile just created before. I add some protocols like RTSP, RTP, and SHTTP. No subnet filters, neither appliance filters are needed here in this setup. I use some default parameters here. The most important element is the use of quality-based policy for primary, secondary, and tertiary links to use always the best available path. Resulted parameters are here, including name, criticality, QoS profile, and path selection policy, which is quality-based. Second use case is offloading internet traffic on the primary SDSL link. So application group name is internet using medium criticality, compression is active, HTTP as main protocol, and other filters are required. And here we have these parameters by default. The important point here is backup as selection mode. So SDSL internet is the default link, other links are backups. Third use case consists on offloading Office 365 and Salesforce through the primary DSL. Office 365 application group with high criticality, HTTP and no other filters are required here. So again, these parameters by default, and the important thing here is backup as selection mode. So SDSL internet is the default link, the resulted parameters here. So name, QoS, and the backup WAN selection policy. Similarly, we have the Salesforce application group using high criticality. The application's instance is Salesforce, corresponding to Salesforce common names. These parameters are by default, secondary and tertiary links as backup, and SDSL internet is the default link. We can see here that new application groups are now on the AQS dashboard. So internet, Audio Skype for Business, Office 365, and Salesforce. Fourth use case is zero-touch installation. So we plug the appliance on the branch office. That requires the Edge appliance. So here we have the Nano engine with 3 WAN ports and 1 LAN port and a configuration port. We have the connection LAN cable, the WAN cable, and also the power. After cabling the Edge appliance, the appliance installation tool should confirm that the appliance is well detected on LAN. The signal that shows that this process is okay is when the serial number of the Ipanema Nano engine appears on the appliance installation tool. So here we have it. So great. Now the orchestrator called Salsa on the customer data centers needs to automatically detect the remote Nano engine on the branch office. Here we have the flows that prove that the Nano engine is connected to the controller. Last use case is troubleshooting slowness on an Skype for Business call between Bristol and Newcastle. First thing is verifying the application quality score. We have top 10 application AQS, including voice over IP. But we are interested on worst 10 application AQS. So Skype for Business has an AQS of 4.29 over 10, so bad application experience. On the Bristol Newcastle line here, I have current throughput, jitter, and loss. And here I can drill down flows per region and country in the coord map. Now I can see Bristol, Newcastle links, flows which are in red. And if I drill down, here I have the real-time metrics of these corresponding flows. So considerable delay is shown in the right graph. You can also have other parameters like packet loss and throughput evolution. So I can also see the top IP sources of traffic. For instance, if I require root cause analysis, it can be triggered considering that these sources of traffic are potential cause of slowness of the G.723 skyformness call. In this illustration, I confirm huge latency variations on the last 10 minutes of the call.